Redis, which stands for Remote Dictionary Server, is an open-source, in-memory data structure store that can be used as a cache or database. An in-memory data structure store refers to a data storage system that primarily operates in the main memory, RAM, of a computer rather than on disk or other persistent storage mediums. It is designed to provide fast, scalable, and highly available data storage and processing capabilities. Redis stores data primarily in the system's RAM, which allows for extremely fast read and write operations. It provides various data structures, including key-value stores, lists, sets, and sorted sets, along with rich functionality for manipulating and querying the data. Redis does not have a built-in indexing mechanism like traditional databases. However, you can leverage Redis data structures and features to create indexes or indexing-like functionality for efficient data retrieval. As a cache, Redis can store frequently accessed data in memory, reducing the need to fetch the data from slower data sources such as databases or external services. By caching data in Redis, applications can significantly improve performance by serving data directly from memory, resulting in reduced response times and lower latency. In the context of Redis, indexing refers to the ability to create indexes on specific data fields within Redis data structures, typically used in Redis key-value store or sorted sets. These indexes facilitate faster lookup and retrieval of data based on the indexed fields. Redis indexing helps optimize data retrieval by creating additional structures that store references to the actual data, allowing for faster search operations. 1. Redis provides indexing capabilities through various data structures such as hash tables and sorted sets. 1. These data structures allow you to define indexes on specific fields or attributes of the stored data. 2. Faster lookup. By creating indexes, Redis can locate the relevant data more efficiently. 2. Instead of scanning the entire dataset, Redis can leverage the index to quickly identify the data associated with a specific value or range of values. 3. Supported data structures. Redis supports indexing on different data structures. 3. For example, you can create indexes on fields within a hash, allowing you to search for hashes based on those fields. 3. In sorted sets, you can create indexes on the scores associated with members, enabling efficient range queries. 4. Trade-offs. While indexing enhances data retrieval speed, it also introduces additional memory overhead and potentially impacts write operations. 4. Indexes need to be updated whenever the indexed data changes, so there is a trade-off between faster reads and potential performance implications for writes. 5. Use cases. Redis indexing is particularly useful in scenarios where fast data lookup is crucial. 5. It can be employed in caching layers, real-time analytics, search functionality, and scenarios that require quick access to specific subsets of data. One real-world use case where Redis indexing can benefit applications is in an e-commerce platform with a product catalog that needs efficient search functionality. Imagine an online marketplace where users can search for products based on various attributes such as category, brand, price range, and availability. Without indexing, the system would need to scan through the entire product dataset each time a search request is made, resulting in slower response times and increased server load. By leveraging Redis indexing, the e-commerce platform can create indexes on the relevant attributes of the product catalog. For example, indexes can be created on the category, brand, and price fields. When a user performs a search for a specific category or brand, Redis can utilize the indexes to quickly identify the products that match the search criteria. Instead of scanning the entire dataset, Redis can perform efficient lookups based on the indexed fields, significantly reducing the search time and improving the overall performance of the application. Furthermore, Redis supports complex data types such as sorted sets, allowing for more advanced search capabilities. In this case, the sorted set could be used to index the products based on their price, enabling efficient range queries for searches like products within a certain price range. By utilizing Redis indexing, the e-commerce platform can provide users with faster and more responsive search results, leading to a better user experience. Additionally, it reduces the strain on the back-end infrastructure by minimizing the computational and I/O overhead associated with searching large datasets.